Hello guys, welcome once more to Prepclass Physics class online, and I'm Tutudami. In this edition, we shall be blasting some aspects of Jamb Physics 2016 question number 11 to number 15, and we shall be destroying those questions and making it simple. Actually, the question has to do with some aspects of physics that many students worry about, and they say, oh, if I meet the atomic physics is very difficult, it's extremely difficult, but actually it's nothing. Then refraction, you say, oh, it's very difficult, but actually it's nothing. Now, only if it is well explained, you will realize that it is something you can do and what anybody can do. Now, don't forget to click on like button if you really learn something from this video. We have loads of content to share with you that will help you better understand physics. Now, let's get to number question 11. Question 11 says a glass plate of 0.9 centimeter thick has that should be thickness, has a refractive index of 0.5. How long does it take for a pulse of light to pass through the plate? We have the speed of light c is equals to 3 times 10 to the power 8 meters per second, and that is the speed of light. Now let's check it out. Now this is under atomic physics, right? Now actually it's not under atomic physics, this is under refraction. Now the reason is because now you can see the refractive index. Now refraction formula is, the sign of incidence over the sign of refraction equals the refractive index. Or we can also use that formula, that's the refraction formula, but it can also be modified into the speed in air over the speed in whatever, in the other material like glass, equals the refractive index. Now in this case, we are dealing with something that has to do with two different velocities. There is the speed in air and there is the speed in glass. Okay, now the speed in air, now the refractive index is therefore velocity in air over velocity in glass. Now we have this now. Now the refractive index that we have here is therefore 1.5, right? Now refractive index is therefore 1.5, and it is equal to the velocity in air, and that's 3 times 10 to the power 8. That's the speed of light in air. Okay, then we have the speed in glass is what we have to first of all find before we can find time. Now let's find the speed in glass. So first of all, the refractive index is 1.5. The speed in air of light is 3 times 10 to the power 8. The speed in glass we don't know because they spoke of glass plates, right? So now we have to find that first. So we will have to cross multiply, and that will give me, if you cross multiply, you divide by 1.5, you'll be getting 3 times 10 to the power 8 divided by 1.5, and that is the speed in glass. Now, and that will give you 2 times 10 to the power 8. Just do 3 divided by 1.5, and that's 2 times 10 to the power 8, and that's the answer for your speed in glass. But the question says how long, that's time. Now you must know that speed is distance over time, right? Speed is distance over time, and the distance in this case is the thickness of the glass. And now we have gotten the speed. Now we have to find the time. So we'll now turn the formula around. V equals d over t, and that means t equals d over v, right? Now the distance in the question is 0.9 centimeter, but centimeter is wrong. Centimeter is like a trap, because distance is not measured in centimeter. You have to change it into meter. That will become 0.9 times 10 to the power minus 2. Okay, that's my distance in meter, divided by 2 times 10 to the power 8, which is the velocity or the speed in glass that we got before from here. 2 times 10 to the power 8, and that will give me my time as 0.45 times 10 to the power minus 10, because I did 0.9 divided by 2, that's 0.45. Then 10 to the power minus 2 times 10 to the power divided by 10 to the power 8, and that will give me 10 to the power minus 10. Then if I put this in standard form, the point will leave here and come this way. When the point move once that way, it will come 4.5 times 10 to the power minus 11, and that is my answer for that question. It will become 4.5 times 10 to the power minus 11, making option B the correct answer, not C. Most past questions will say option they will pick the wrong answer, but that's the wrong answer. The real answer to the question is B, 4.5 times 10 to the power minus 11, and that is the answer to the question. Let's check out number 11 now. number 12. The main purpose of the transformer in an AC radio set is to what? Now you know that transformer is something that step up or step down voltage. A transformer, you know, we have two types of transformer: the step up transformer and the step down transformer. But in an AC radio set, what do they do? Very simple. Transformer are most commonly used for increasing low AC voltage at high current. A step up transformer, okay, or decreasing high AC voltage at low current. So it can either increase voltage or decrease voltage depending on the current. Now, you know, when electricity comes to your home, it comes from the main from the transmission system outside, and that transmission system is sent from NEPA or the PACN, the Power Holding Company of Nigeria, at high voltage and low current. But when it comes to your home, it has to be changed into high current and low voltage. And that's what a transformer does. A transformer helps to lower the voltage. So it has to decrease high AC voltage at low current. Okay? So it has to step down. It is a step down transformer. The transformer helps to step down the voltage and increase the current. So when you are stepping down voltage, you are automatically increasing the current, because light comes to us from the PACN at high voltage and low current, but we use light at high current and low voltage. So the transformer helps to convert it. It changes it from high voltage and low current to high current and low voltage, and that's the way we use it in our home. In our home. So it is important. So that's the work, and that process of changing the voltage is called step down process. So that transformer is called a step down transformer. It tempers down the voltage. It step it down, and that's the answer to the question. So it helps to step down the voltage so that the current will be high, and then you can use it for your radio set at home. And that is the answer to the question number 12. Let's check out number 13. The energy associated with the emitted photons when a mercury atom changes from one state to another is 3.3 eV. Calculate the frequency of the photon. Now this is under atomic physics. Now you can see Planck constant H, 6.6 times 10 power minus 3 joule per second, joule seconds. And you can see the energy there. That's the number of electrons there. Now E equal 1.6 times 10 power minus 9, right? Coulomb, that's the charge of the electron. Now we need to find the frequency, but you must know further in atomic physics that the mighty formula of this topic is E, that's energy, equals FH. Okay, now but you are told to find the frequency. So anything photoelectric equation, I call this the photoelectric equation. That's E equals FH, because this equation is what's used to solve questions on photoelectric effects. E equals FH, where my E is my energy, my F is my frequency, and my H is my Planck constant. Now, and that's it in the question. So now we have to find the frequency. So make the frequency the subject. That will become F equals E over H, right? Put the H under it, right? And that will be F equals E over H. Now my F is therefore, what's my energy? My energy in the question is, I'm giving 3.3 eV. That is the electrons. Then the energy of the electron is 1.6 times 10 to the power minus 19. So that means this energy times this number of electrons, and that will become 3.3 times their energy, 1.6 times 10 to the power minus 19. Divided by the H, the Planck constant, 6.6 times 10 to the power minus 34. And that will give me, if you work on the number, I always say number first. 3.3 times 1.6, get your answer, divided by 6.6, you will get 0.8 times 10 to the power minus 19 divided by 10 to the power minus 34. That will give you 10 raised to the power 15. Now put your answer in standard form. This point will come from here to this place, and that will now give you 8 times 10 to the power 14, because it will reduce 1. And that will become 8 times 10 raised to the power 14. And that is your answer. Don't forget, it is just this way, and that is the way to go. The photoelectric equation is very important. E equals FH, and that is the simple answer to the simple question. Next time you see it, blast it. Now that settles this one. Number 14. So my number 13 is D. 14, we have uranium, and you have N, neutron, and then it produces barium and krypton, and it has 2x. Now it is asking that in the reaction above, S is what? Now do you have any idea what the X might be? Now you can see that this is equal. This is what? 235. If you mix this up, you'll be getting what? This and this is 234, if I'm right. That's 234. And this plus this is what? Is actually 92. So that is, there is actually one extra here. Now for this, so what is the X? That's the last guy in this equation. Now this is actually a nuclear fission. This is a nuclear fission. Now one is splitting into many. One nucleus is splitting into many. Sorry, one nuclide is splitting into many nuclei, and that's barium and krypton. So now we have this now. Now what will now be my X? What's the symbol of X? Is it electron, neutron, neutrino, or proton? It is not proton, it's not neutrino, it is simply neutron. And that is what you have there. The answer is just neutron. It is not producing electron because it is not negatively charged. These guys are positively charged, but electron is they are all neutral charged. So the answer is neutron, not electron. Electron means it is negatively charged, and that is not the answer. So the simple answer is just neutron, and that is, it is producing 2 neutrons, and that's your answer you get. Number 15, to protect a material from the influence of an external magnetic field, the material should be kept in a what? If you have a magnet and you don't want it to lose its magnetism or to be affected by the external magnetic field or whatever, you are trying to protect from the magnetic field. How can you protect it? Keep it inside what? Or around what? Is it a soft iron ring, or a loop of copper wire, or triangular zinc ring, or square steel ring? Now, under the topic of magnetism, we learned how to protect things from magnetism, right? Now, under that topic, we learned that iron is a ferromagnetic substance. So there are no magnetic line of force inside iron. Iron is that deadly. Iron does not affect allow magnetic flux or magnetic line of force around it. So to protect the sensitive equipment from external magnetic field, it should be placed inside an iron can, because magnetism can't penetrate through iron substances. So iron is a ferromagnetic substance, and there is no magnetic line of force inside. So magnetic line of force can't enter through it, can't get through iron material. So the simple answer is just soft iron ring, and that is the answer to that simple question. Now that brings us to the end of this video. Don't forget, if you learned something from this video, click on like button. We have more contents that will better help you understand physics. Until we see next time, guys, take care of yourself and bye for now.